this electric field question. So this question imagines this scenario here pictured on the left in a uniform electric field. So we don't know exactly what the electric field looks like, but we know that it is uniform. So it's all pointing in the same direction and it's all at the same magnitude. And the question tells us that the distance between A and B is the same as B and C. And then the distance between A and D is twice the distance between A and B. So I've labeled this as 2D for the distance between D and A. And then A to B and B to C are labeled as D. And then this point E is directly above point B at an angle with A of theta. And this question gives three scenarios with three different charges, all starting at rest at point A. And it says that charge Q1 is a negative charge, and it picks up a total kinetic energy of delta K as it goes from A to B. Q2 is also a negative charge, and it picks up a kinetic energy of delta K, same as Q1, but going from A to C. And then Q3 is a positive charge that starts at A at rest and then picks up 4 times delta K in kinetic energy as it goes from A to D. And then the question has a bunch of statements and it asks which ones are true. Now, for this setup, since you have 3 hypothetical charges and you're told what kinetic energy they gain from rest, it's important to figure out, okay, how do I convert this to to measurements that I can actually work with. And the biggest relationship here is knowing that the change in electric potential is your electric field dot product with your displacement. Because the electric field is excuse me, because the electric field is constant everywhere, this actually reduces quite nicely to E times your change in distance times the cosine of your angle. The angle to the electric field line's not to this theta, which is why I put phi in here instead of theta. And then the relationship between it and potential energy, because we're working with kinetic energy, so it's better to understand potential in terms of potential energy instead of electric potential. And so that's just the charge in question times delta V. So we got this relationship between your potential energy and our electric field and our charges. And from kinematics, we remember that in a conservative system, which according to this question, the only forces being applied are Coulomb's law. So this is a conservative system, no friction. The kinetic energy is gained is equal to the potential energy lost. That's what the minus sign represents here. And so if you take the kinetic energy that each of the charges gains by moving through this problem, we can set up our equations. So we can take the potential energy for charge 1 being the charge of charge 1 times the electric field times the distance traveled, which is D, goes from A to B. And then we negate that to make it equal the kinetic energy it gained. So minus Q1 E times D is equal to delta K. Likewise, for charge 2, its distance was 2D. It's in the right-hand direction. So it goes from A to C. And so we have negative Q2 times the uniform electric field times twice the distance from the first charge is equal to the same kinetic energy. They were given that they're both the same. And then for charge 3, it's a positive charge, and that's why so it moved to the left. And so it's negative charge 3 times the electric field times the negative 2D because it's going to the left. So the displacement direction actually does matter. And so this is equal to 4 delta K. Now, a lot of these statements ask what the relationship between charges is. And with these 3 equations, you can figure out the charge relationship between Q1, Q2, and Q3 based on what these statements ask. So it says, the first statement says the magnitude of charge Q1 is 1/4 the magnitude of charge Q3. So you just find, based on this equaling delta K and this equaling 4 delta K, you can set up an equation to figure out the relationship between Q1 and Q3 to see if that sentence is true or not. Most of these so a lot of these statements involve those kinds of relationships, asking which one's right. And then you have a question: if Q1 moved from A to E, it would lose an amount of electrical potential energy equal to delta K, and then it says the same thing but equal to delta K cos theta. And for that one, I would just suggest, like, here's the definition of delta V, and this is how it relates to delta U. And so you should think through what that means, as far as what's the change in kinetic energy or the change of potential energy, and whether that changes based on whether you're at an angle or not. And then another question says that the field points to the right. You can use your understanding of electric fields to tell, okay, based on where the charges went, which way must the electric field be facing? And then yeah, so you should have all the information you need to actually solve this problem. If you get stuck at a certain point, you can always leave a comment and I will try to nudge you in the right direction. But give it a shot with what information I've given you, and best of luck.